Hi everyone. I wanted to give you another example. Some of your online homework involves you calculating a class width and then finding the lower and upper limits and the lower and upper boundaries. So I wanted to give you another example where it kind of includes this whole table that your online homework is asking you to fill out. So the first thing that you're going to need to calculate is something called the class width. And the class width is always found by finding the highest value on your list of numbers, subtracting off the lowest value on the list of numbers, and then once you get that number, dividing by your number of indicated classes. Let me make this bigger. Okay, so you're going to do highest number on your list minus lowest number on your list divided by the number of classes that are indicated. Now, sometimes the number of classes is listed in the problem. Sometimes you just have to look at your table and see how many rows you have, okay? So looking at our data, sometimes the data is ordered from smallest to largest, and sometimes it's just a mess all mixed up together. So sometimes you gotta look for it. But in this case, our highest number is that 86. The lowest number is the 21. And we're going to divide by, if you look at the table, we have 1, 2, 3, we have 4 classes, okay? And that number could vary. It's just the number of rows, or in the problem it will say how many classes to use. So on your calculator, you're going to do 86 minus 21, push enter, and then divide by 4. In this case, I'm getting a 16.25. Now, this is odd. The next step that I'm going to tell you is kind of a strange step, and this is the only time that we do it. No matter what decimal value you get on your number, you always round up. Always, always. Whether it's a 0.0, a 0.2, or a 0.9, you will always round up. So in this case, we are going to round up to 17. That is your class width. Okay, so high minus low, divide by the number of classes, and then always round up no matter what the decimal to the next biggest whole number. Even if this was 16.0, you would round up to 17. Okay, now for your table here, your lower class limit will always be your lowest number. So in this case, we have a 21, okay? And then to go down your table, to go from here to here, you're going to use your class width. And to go from here to here, you're going to add your class width. And to go from here to here, you're going to add your class width. So to go down your table each step, you're going to add whatever the class width is. In this case, it's a 17. So the 21 plus the 17, we have a 38. Okay, make sure you kind of see where I'm getting that. Taking that 21 plus the 17, I got a 38. The 38 plus the 17, we're going to get a 55, and the 55 plus the 17, I have a 72. Everybody with me so far? So each step to go down the table, you add the class width. That's why we want to calculate that class width first. So far, so good? So what we have found so far are the smallest numbers in each class. But now we need to find the upper numbers in each class, because each class is a range of numbers, from this number to this number. Well, the way I look at this is going from 21 to something, and the next class starts at 38 to something. Well, if your second class starts at 38, then the previous class has to stop at 37, because you don't want any overlap, okay? And then the next class goes from 38 to something, but then the next one starts at 55. So if this guy starts at 55, that means this guy has to end at 54. Another thing to look at though is, just like I said, to go down your table here, you need to add 17. Same thing here. 37 plus 17, if you do that, is also 54. 54 plus 17 is 71. Conveniently, that's one below the next class. And then 71 plus 17 is 88. And the only way to get that 88, that highest number, is to use that class width. Okay? So those are your upper and lower limits, and those are like ranges. That's saying from 21 through 37, that's your first class. From 38 through 54, and so on. Okay, so this is a range or an interval of numbers that make up each class. For your class boundaries, you're going to kind of worry about decimals. Eventually, we're going to be making a bar chart or a histogram out of this information. And to do that, you want your bars to be touching. And the way to do that is to worry about these decimals. So you're basically going to bump down the lower limits by 0.5, and you're going to bump up the upper limits by 0.5. So if I'm going to take off a 0.5 from 21, I'm going to get a 20.5. And over here, I'm going to bump it up. I'm just making my interval a little bit larger. So then I get a 37.5. Here I have a 37.5. Notice our bars would now be touching. 54.5. 54.5 to 71.5. 71.5 to 88.5. So far, so good? Based on some questions that I was getting, it seems like that's where people were having questions, kind of over those columns there. But let's keep going here. Let me zoom out so I get the whole table. Midpoint, just like if you go back to basic geometry, the midpoint is the middle, okay? So you're either going to find the middle of your upper and lower limits, or if you like decimals and would rather work with these guys, you're going to find the middle of those numbers, whatever you want. For each class, I'd rather work with the limits because they're nicer numbers. So I'm going to take 21 plus 37, and I'm going to divide that by 2, and I'm getting a 29. Okay, to find a midpoint, you add up your two ends and divide by 2. Add up the two end values for each class and divide by 2. 38 plus 54, enter, and then divide by 2. 55 plus 71, enter, divide by 2. And one thing I want to point out as we're going, this class width that we had, it's useful here also. 29 plus 17 gives you that 46. 46 plus 17 gives you that 63. So that class width, to go down your table, it works for every column thus far. Okay, it doesn't hold true for the frequency stuff, but thus far it does. And the last one is 72 plus 88. Divide by 2, which is 80. And you can double check your math there by seeing that 63 plus 17 is 80. Okay. Next column is frequency. That's just literally how many data values here fall in the range that you're looking at. So our first class is for all those numbers between 21 and 37. So I'm seeing, let me zoom in a little bit. These values are a little small. These guys here. So I'm going to count up. We have 1, 2, 3, 4. I have 5 numbers in there that are between 21 and 37. So I have 5 data values. So frequency is just how many numbers are in this category. The next category is from 38 to 54. So far I went up through here. So I'm just going to kind of put a break. So my next one's 38 to 54. That brings me up to here. So I have 1, 2, 3, 4, 5, 6, 7. And that is our frequency there. With me so far? The next category is from 55 to 71. That would bring me to here. Those are not ones, that's just a breaking spot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers fall in that category. And between 72 and 88, that should be the rest of the values. 1, 2, 3, 4, 5, 6, 7, 8. And I always like to total these because I'm going to need that number next. So 5 plus 7 plus 10 plus 8 to 30. I'm getting just a total of 30 numbers here. And I like to go back through and make sure that I do have 30 numbers. So it looks like I have 6 numbers in each row, and it looks like I have 5 rows, so 6 times 5 is 30. So far, so good? Okay. So relative frequency, this is the percent column, okay, or written as a decimal. So now I want to know basically the percent, but write it as a decimal, that each category makes up of the total. So if I have 30 numbers and 5 of them fall in this category, I'm going to do 5 divided by 30, and I get a 0.16666 repeating. I'm going to round this to 2 decimal places because it doesn't specify, so I'm going to say 0.17. 7 divided by 30 is 0.23 repeating. So rounding that to 2 decimals, I'm getting 0.23. 10 divided by 30 is 0.3 repeating. So I'm going to say 0.33. And 8 divided by 30 is 0.27. And since those are kind of representing percents of a total, but they're written as decimals, these should add up to 100%, or in other words, 1. So I always like to go through and add up those numbers and make sure they add up to 1. Or if they don't add up to 1, they could add up to 0.99 or 1.01, and that would strictly be due to rounding. In this case, they do add up to 1 though, okay? The last column is cumulative frequency. There are 2 ways to find cumulative frequency. You can either add up the frequency column or you can add up the relative frequency column. We in this class are going to focus on adding up the relative frequency column. Some of the homework has you add up the frequency, but I'm getting that corrected, so I apologize if you run into that problem. But what we're going to be doing for cumulative frequency is we are going to be using relative frequency. So for the first cumulative frequency, you just carry this relative frequency straight over. For the next cumulative frequency, you're going to take every relative frequency in the rows above it up into where you're looking. So for this guy, the second row, you're going to add up 0.23 and 0.17. Okay, so you're going to use every relative frequency in the row that you're working with and above. So 0.17 plus 0.23, I'm getting 0.40. For this guy, you're going to have the 0.33, 0.23, and 0.17. And we are getting 0.73. Adding those up. And for the last one, you should be adding 0.27, 0.33, 0.23, and 0.17. And hopefully that's 1.0. On the off chance, it could be slightly off of that, and that's, again, strictly due to rounding. Okay? As I went through that, I would recommend make sure you're writing little notes to yourself about how to do each column. Okay, it's very repetitive, so the more of these you do, the better that you'll get. Okay, hopefully that helped you out there. Good luck.